Hello,
All right.
dear friends, and hello, Bernhard. Welcome to our interview with Bernhard Rischka, Director of Corporate Technology at Swiss Steel Group. Bernhard Rischka has been working in the steel industry for over 30 years. Today, he is responsible for technological development, sustainable innovation, and the transformation of production processes at one of Europe's leading producer of special steels. Under his technological leadership, Swiss Steel Group has achieved unprecedented results in decarbonization. In 2024, the company became the first steel maker in the world to have its sector-specific emission reduction targets officially approved by the Science Based Target Initiatives. Bernhard has already given a presentation to our community on the company's CO2 reduction initiatives, which was very well received, and you can watch the recording via the link that my colleague will share in the chat. And now Bernhard has kindly agreed to answer questions I didn't have time to ask him during our first episode. Again, hello Bernhard, and nice to see you here. And yes, and before we begin, let me briefly introduce the company behind this podcast. I'm currently leading two projects, Smart Scrap and Smart Metallurgy. Smart Scrap is a global trader of metallurgical waste. Right now, we are in the process of transforming the company into a full-scale recycling operation. We are negotiating slag processing projects in several countries around the world, and we are actively looking for investment partners. If any of our listeners are interested in learning more about these projects, feel free to reach out. We will be happy to connect and talk. In our second project, Smart Metallurgy, we help electric arc furnace plants to improve their operational efficiency. So my colleagues will now share the link to our website in the chat where you can learn more about who we are and what we can do. Okay. Bernhard, I have been thinking about the goal we could pursue in this interview, and one idea came to my mind. Today, the steel industry stands on the threshold of major transformation. On one hand, the push to reduce CO2 emission are significantly reshaping the technological process themselves. On the other hand, we face market challenges. The crisis of overproduction forces companies to seek new solutions just to stay competitive. And at this moment, I think that you agree that industry needs young people who are ready to bring change and drive improvement. And by young, I mean not only in terms of age, but also in spirit. And these new leaders of changes need knowledge and experience, which accomplished professionals like you can share. So today, I would like you to try to tell story of your career so that our audience might find some ideas or even inspiration through our conversation. Do you mind?
Yeah, Andre, good afternoon, and hello to all the listeners. And thank you for providing me the floor once again this afternoon. First of all, I want to put my personal person a little bit on the backside. You mentioned I'm a top executive, but unfortunately, the top executive works above me, yeah, at least in terms of salary. So I work here in Swiss Steel Group. If you allow me for a minute to introduce the company, we are not a steel plant. We are a group of steel plants. We operate in Switzerland, in Germany, in France, in USA, in Chicago, as well as in Montreal, in Canada. And when I say operate, this is where we have major process steps like melting, casting, forging, or rolling, and so on. And then all over the world, we have a lot of heat treatment, pickling, and machining shops, and so on, so on, and so on. And I work, so altogether we are 7,500 employees. Uh, I work in the holding here in Switzerland. We are approximately 40 guys or ladies as well. And for me as a metallurgist, it's very interesting to see all the markets, all the different cultures, personalities. And so I always keep saying I have the best job in the world. But I'm not Steve Jobs. Probably the question how to become an say to make a little bit career is a more general question, and this is what I've been asking myself in the last 30 years. How can you become from a graduate, work in the right niche, and then be promoted and make a career, finally a career? And I think the answer to this is not so simple because in my case, as a metallurgist, of course, I studied metallurgy, and then it's quite clear you work in the ferrous industry, you work in the non-ferrous metal industry, and of course, my the benefit I always had was probably the expertise you gain from material science, you gain from process which you learn first in the university, and then of course when you start your career, you work for one company and probably then for another. But this is not the only path to become successful. I've seen guys or ladies who started in the consulting business. Yeah? So they start in consulting business and then they consult everything from a chocolate factory to a steel plant. And then they make connections, networking, and probably at the age of 30, 35, they immediately jump over stepwise career and just go into vice president of whatever or managing director. So if you and these are the people who tell you don't be too close to the product to make a career. So what I'm seeing is there's both. You can be an expert in your field, in your area, as good as you can, and then move up a little bit in my career ladder. Or you can also be an outsider, I say, and coming from the management and consulting business.
Mhm, mhm. Okay. But so when you tell that you are not Steve Jobs, I agree that there are a lot of like podcasts today about successful, etc., and from celebrities, from businessmen, from sportsmen. But I think that it's very important that people from steel industry, from top position like you work in a big company, it's and in a management position, and it's very important. I think that also to know your experience and. Okay, so you already mentioned about the university, and I've read on your LinkedIn that you graduated from University of Leoben in 1991. Yes, more than 30 years ago. Could you briefly describe how the education was structured at that time? Did you have any practice experience at steel mills during that time?
Yeah, well, thank you for mentioning 1991. It feels like 100 years ago.
Yes,
But yeah, I studied Leoben in Austria is small and also the only one university in Austria where you can study metallurgy. You have a few in Europe. I think you have one or two in Germany, Poland, Czech Republic, and so on. But basically, the area of metallurgy, or let's enlarge it a little bit, like with material science, which could also include ceramics and maybe some plastics and so on, is still a small business compared to common machinery or electrics or electronics. So in my university, we were uh, approximately 2,000 students. Half of them actually went to university. The rest didn't attend and dropped out very soon. It was structured that after 5 semester, earliest after 5 semester, you have an intermediate step, which would be probably today the bachelor degree. And in this period, you learn everything about the basics, starting with a lot of mathematics, chemistry, physics, machinery, and so on. Also design engineering, and so on and so on. And when you finally master this first step of larger test, then it goes. You have to decide if you want to go rather into material science or especially into steel or in non-ferrous or ceramics and this kind of departments. And this takes another four, four semester. So you're talking about 4.5 years. And then on top, what is required is that you need to collect 6 months of practical experience as a student, probably during the holidays, summer holidays or winter holidays, where you work in an industry, either in the steel industry or in an industry affiliated to the steel industry. It can be a refractory or ferro alloys and so on. And then after 9 semester, you make a thesis, you write your diploma works, which takes again half a year. So theoretically, you could complete the study within 10 semester, 5 years. I think the fastest in our place was 12 semester, 6 years, and I needed 7 years. which is more or less the average. What I forgot to mention in the first question, Andre, is actually what I've learned is whether you are drawn by expertise or you have networking coming from consulting or whatever works. The most important thing, and this is what I tell to my kids, is that you like the job you do. So
Mhm.
if you become a lawyer just to make money, I can promise you will be a bad lawyer or a dentist and so on. So, and I was always a little bit attracted to metallurgy when you start university at ages of 18 or 19. Of course, you're not quite sure, do I really like it? So it's always easy to say, okay, after 1 year, I've tried it. It's not my piece of cake. I want to change. Yeah. But in the end, it's important that you really are attracted and you like what you do. Yeah.
Yes, yes, yes. I agree with you. And when you came to when you decided to go to this exactly this university, it was because of it was near of your town or because you like metallurgy and to.
No, it was not. It was not. Actually, I grew up in Germany, in the German part, close to the French border,
Mhm.
to the triangle Germany, Luxembourg, and France. And this place, Leoben in Austria, is 800 kilometers away. Back in the 90s, this was a huge distance. No, I think it was my father who convinced me because to go to Leoben, because also he studied in the same university. So it was a little bit kind of uh, following the heritage. And also my grandfather, he was not a metallurgist, but he worked in the refractory business. So 2 or 3 generations, we are all linked to metallurgy. I'm happy that my son, he does something completely different. He studies physics, yeah, and the daughter, she studies, I don't know, some other things, because I believe metallurgy is getting more and more challenging in the future, especially in Europe, in Germany. The industry is in the defensive, so we're rather losing people in the industry, and this goes hand in hand with the young people who don't feel attracted to the steel industry too much anymore. Because today you want to work in consulting, you want to work in IT and so on. Who wants to work in a dirty steel plant, probably working on shift and so on? So there are less and less people. Uh,
Yes, yes, yes. Because for example, when you work in IT sector, you have coffee bar, etc. in the office, yes, and
yeah, yeah,
yeah, but when you work in steel sector, so it's
yeah,
now it's you agree with that it's more challenging today to have young people.
yeah,
Yeah.
yeah.
Mm-hmm.
We see this definitely by our HR department. But I also have to say that uh, it's not necessary nowadays anymore to study metallurgist. A steel plant needs many, many more different expertise than just a process metallurgy and so on. So and that's why I believe the steel industry, in my eyes, is still sexy because we have IT specialists who come
Mm-hmm.
from SAP, who come from IBM and so on. We have expertise on maintenance, mechanical maintenance. We have, of course, business administration guys. So there is a whole potpourri, a whole melting pot of expertise which you find in the industry. Probably you will not find in Siemens. I don't know if there is a metallurgist working in Siemens or in Bosch or in another big company. So this cross-functional expertise in the industry is for me always I find it quite attractive. And I'm also not saying I'm saying that the European, especially the German steel industry, is on the defensive, but we have one strong asset, and this is the scrap, and that's where you come in. Yeah, I think our economy in Europe and in the USA is an old economy. So this scrap which comes back after 20, 30, 50 years, uh, this is available in Europe, in Germany, and that's why we will always have a minimum of a steel industry. In
Mm-hmm.
India, or in China, the motivation is different. They have no real scrap. That's why in China you have 90% of steelmaking comes from blast furnace and converter shop. In India, it will not be much different because the revert scrap is not yet coming in. I mean, look at the life cycle of a bridge is 100 years. The life cycle of a car is 15 or 20 years, and so on. And so we in Europe and in the western part of the world, we have the privilege that there is already a lot of scrap available. And I think the European Union, we export 19.5 million tons of scrap every year, and it goes to Turkey, it goes to Egypt, it goes to Pakistan, and so on. But in the end, I think the scrap will more and more stay at home in
Mm-hmm.
Europe, and then we will convert it to a better product.
Mm-hmm.
So it's not the end of the steel industry.
It is not the end of this. But
And
so,
then, sorry,
mhm.
and finally,
Yes, 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 yes.
let's not forget there are other parts in the world where the industry is booming. If you look in China now makes 1.1 billion tons of steel. They have their trouble, of course, because they have built too much, have been too much in construction and so on, yeah, infrastructure. But India is just on the rise, and the American market is good. South America, I'm not quite sure, but Africa has not yet even started. So there are other parts in the world where the industry is quite a booming sector, I would say.
Mm-hmm, 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 mm-hmm. I understand. So, you mentioned that HR specialists tell you that right now you don't need specialists with metallurgical education, right? So, can you explain it?
Yeah, no, it's what I'm saying is you don't need exclusively metallurgical expertise when you operate a melt shop. We
Mm-hmm,
have many melt shop managers who are actually studied electrotechnics. We have
mm-hmm,
rolling mill managers who come from the maintenance side and who studied machinery,
mm-hmm,
mechanical engineering, and so on. Uh,
mm-hmm,
And of course, in each process step, you do have some uh, metallurgical backup from one or two or three metallurgists. But also these guys, they don't work in one department anymore. They work not only in rolling or in forging, maybe they're also in charge of heat treatment or in charge of steel making and so on.
mm-hmm,
So it's for me, it's an exciting teamwork of smart people with different educational background. And that's for
mm-hmm.
me, I find it very, very attractive.
It's interesting, but anyway, so you have some internal education, right? So before they start, there are some educational program inside of Swiss Steel Group because if they,
Yes, of course,
Mhm,
there is. So for blue collar, for example, we most of our plants, they have this apprenticeship program where you can study how to become a pipe fitter, a welder, a mechanic, or an electrician. And also for the white collar, we also have some educational programs, most of the time outside of the group, but we send them on seminars. People make MBAs and so on, yeah, which
mhm,
are partly subsidized by us. Yeah.
It's interesting. It's when I heard uh, this way of teaching people and involving people in the production. I remember a story of my metallurgist, and I would like to share. It's my colleague and my mentor. His name is Andrei Alexandrov, and he started working in a steel plant when he was just 17 years old. And by the age of 30, he was awarded the honorary title of Distinguished Metallurgist of the Soviet Union for his outstanding results. And at the time, Ministry of Metallurgy used to honor the country's best metallurgists, but it's worth to mention that he did not have any formal education that time. He got it later just to take management position. Like it's for sure education is very important, yes, because you spent, as you told, 7 years, yes, for
Mhm.
to get this. It's very important. This background is very important, but also practices and team working is also crucial to become a successful metallurgist, as we discussed now. It's today we try to find these factors, successful factors, to be good metallurgist, yes, to achieve some.
Yeah.
Yeah, yes, yes.
Yeah, I have my due respect for this kind of hands-on people who start making apprenticeship and then they work year by year and get more and more responsibilities. And especially in Asia, I think I have a lot of respect for Russians as well because they have a very clear thinking, a very clear strategy. They know the process. I'm talking about the metallurgists and the white people there. And I spent a few weeks in some uh, med shops, and also the Russian in particular, they are very clear on they understand the technology. Because in Germany, I was born in Germany, so I can criticize a little bit. So
Mm,
maybe you have a metallurgical expertise, but you don't want to be exposed too much to maintenance, to equipment, technology, or to automation and so on. I haven't found this kind in Russia. In Russia, there's a kind of comprehensive approach of very smart people inside and probably also outside of the steel industry. And I can go on to other countries in in Turkey, hardworking people. I remember once I was 24 hours in Çolakoglu in a big 300-ton electric arc furnace melt shop, and I had a translator, a counterpart, Turkish guys. And after 24 hours, I said, I'm going home, I sleep. And
mhm,
when I came back after 6 hours, this guy was still there. So hardworking guys. In America, what I find compelling, keep it simple. Keep it simple because many times, so they don't have apprenticeship for steel making. So these
mhm,
are sometimes farm boys or guys who used to drive Uber, and now they get more money in the steel industry. So they're also hands on without expertise. And then it's the process is as simple as possible for
mhm,
everybody to follow and to understand very quickly.
mhm,
Uh, in Australia, everything is about safety, I find, and so on and so on. So different countries, different approaches.
mhm. I had this question about like because I know that you travel a lot and you work in many countries, yes, and if this approach, yes, but as for methodologies, is there any some kind of similarities between methodologies in different countries?
I think there is because the basic steel making has a little bit standardized. Because if you're honest, I think there are 3 or 4 big technology provider. I'm talking
Mhm,
about the Danielis, the SMS, the Prime Metals, and there may be 1 or 2 more who have supplied their equipment all over the world. And by doing so, they have introduced a certain technology standard. So
mhm,
if you go to a furnace nowadays in Egypt, it may be much more modern than our furnace here in Switzerland or
mhm,
somewhere else. But having said that, still, I don't think there are 2 furnaces or 2 casting machines in the world who are identical. Everything is a little bit different, but at least the technology is very similar, I would say. Yeah.
mhm, mhm,
So
mhm,
the metallurgy is always also a little bit similar, I would say, because the basics are the same, and probably uh, in some countries you have, as I said before, rather clear interfaces from your responsibility to pass it over to another guy with another responsibility, whereas in other countries probably there's more a cross-functional responsibility that you are more in charge of many other things. And some people like to remain specialists. They like to work in the lab or they like to work somewhere else in maintenance. And then there are other guys by personality, they want to be more generalists. Yeah.
mhm,
And I think there are probably not only different countries, but also differently sized steelmaking companies who offer this different kind of approach. I think the smaller the company, the more responsibilities you get, which is not a surprise, I would say.
mhm, mhm, mhm. And so, as for mentality of methodologists, as we had one of the episode in this podcast with Victor Macha, we discussed that methodologists are quite rough and tough people, yes, because of his the environment, his dirty environment, etc. And you also mentioned and people like rude and rough from outside, but very kind from inside, as we discussed to him.
Yeah, this is true.
Yeah, yeah. So let's move on. And so, according to your LinkedIn profile, your work history started on LinkedIn from 2015. You work in United Arab Emirates and SMS Concast, and since 2022 17, you have held a leadership position in Swiss Steel Group. But after the university, where did you begin your career?
Good. Thank you for asking. I didn't make holidays for 14 years. So when I graduated in 1991, then came the military service, of course,
Mhm,
uh, and then I started in SMS Concast
mhm,
for the first time. And this actually that time it was called a Concast because there was no merger yet. And Concast that time was an equipment supplier for uh, for mainly for continuous casting machines, but also for melt shop equipment. And I started as a commissioning engineer, which means as a customer in China or in Australia who orders your equipment, and then you build it, you design it, build it, supply it. And my part was coming in for training, and then later when the construction was almost completed, we started with single tests, integrated tests, and then hot commissioning as a startup. And then you stay there for a few months or even 1 or 2 years to make the final acceptance tests.
mhm,
So the largest plant I was working on took almost 2 years. This was in Bahrain for heavy jumbo beams. This was a turnkey job together with SMS and Samsung. They made this was land reclaimed from the sea, and then you pile, and then you make the construction and so on. And I was there 1.5 years to get the final acceptance
mhm,
certificate.
mhm, mhm,
So sometimes you only have a small revamping, modernization. You go there for a few weeks, and on the other side of the spectrum, you have a very long commissioning time. That time I did this for almost 10 years. I was very much attracted. I liked it. I was not married, no family yet, and this, of course, is a problem. The older you get. So after 4 years, I changed to Comcast in Hong Kong, serving the mainly Asian market. Then I changed to Comcast in Pittsburgh in the United States for North and South America. And after 10 years, I decided to leave, and I quickly joined a refractory company, RHI. Now
mhm,
it's RHI Magnesita, the
mhm,
number one in the world. Then I was 12 years. I was crazy job. I did my own consulting business and as well as trading. So together with two more guys, we purchased refractory graphite electrodes, special ferroalloys mainly from China, and supplied it to customers in mainly Austria, but also a little bit in Germany and Slovenia. Yeah.
mhm,
And then in 2015, that's where you have my LinkedIn profile. That's when I joined in Emirates Steel. Yeah. So it's SMP number two. Emirates Steel makes 3 million tons of steel. 2.5 million is rebar, and maybe 500,000, 600,000 tons is jumbo beams which you need for subways, for airports, and for heavy construction. And there I was in charge of production, metallurgy of the melt shop, and I was also the link to the hot charging part of the rolling mill. Very good experience. I had to leave quite early for personal reasons because the kids were there, and then the wife was complaining. I was away too long for a time.
mhm,
Uh, and then I joined Comcast again, and I was thinking I would retire there. And then a headhunter offered me this job here in Swiss Steel Group. So that's how I came here. Now I've been with the Swiss Steel Group for 9 years. I'm 61 years old. We have another 4 years. In Switzerland, you retire at the age of 65. And I hope I can still work so long because I still like my job. I like to go to work every day.
yeah, you are full of energy and you are young
Yeah,
in spirit, and so I see. And you used to live in so many countries, yes, in different continents, and is in so many different projects with so many different people. Oh, it's
yeah, this is surprising if I compare myself to my brother. My brother was born in Germany, he lives in Germany, and he will stay in Germany forever. And I was rather the gypsy. And as I said, just give you a small insight about my family. We are four, so a wife and one daughter, one son, and we were born on three different continents. Yeah, so
Mhm.
the wife is from China. The daughter was born in the U.S., and my son and I, we were born in Germany and Austria.
Wow.
But this is something you have to like, and I really, it was for me easy to connect with everybody, all kinds of persons. Also with a university degree or shop floor persons, and this was for me, or still is, a little bit a small adventure. And
Mhm.
until today, I like it. I learned things in Cape Town in South Africa, as I've learned things here in Swiss Steel Group. I think this life is a never-ending learning story, and
Mm, yes.
don't believe that you know everything.
Yes, it's also one of the key of secret, yes, because when, for example, when we visit some steel mills to tell them that we can help them to improve the efficiency, it's very hard to to uh, to persuade them that
Hmm.
they tell that
Hmm.
we know everything and we don't need anything. Like
Yeah, yeah,
yes, yes, yes.
yeah.
Yeah. So now you're in Swiss Steel Group. So what is the key responsibility you handle as a director of corporate technology in the
Yeah,
Swiss
yeah.
Steel Group?
So we are not only a group, we are also on the stock market,
Mm-hmm.
and so the stock market has a clear, how shall I say, this depend or since you're on the stock market, you have to have departments which other companies would not have. We have to have a strong legal department, a strong department for communications, and so on, uh, HR, of course, and all these departments, they are in the headquarter here, these 40, 45 guys. And then they said, oh, hold on a moment. Now we have all these kind of departments. How about technological expertise?
Mm-hmm.
Or operations or CTO and so on. Yeah. And that's why we also have a small group of 4 or 5 guys. And this is where I work. This is my department. And my job personally is to handle major investments. For example, so we spend, it's no surprise, we spend 100 million euro on capex every year and 100 million on repair and maintenance opex. Uh,
Mm-hmm.
then we, of course, we want to be to decarbonize. So there's quite some money coming together, and to make sure that there is a strategic view, that there is probably also a harmonization in terms of supplier. This is where I come in.
Mm-hmm.
Secondly, I mentioned before we have 6 melt shops, 6 arc furnaces, 5 rolling mills, 4 forging shops, and more than 100 heat treatment shops. So it also makes sense to make an internal friendly benchmarking. This is
Mm-hmm.
also my part. What is your yield? What is your energy consumption? What is your productivity? And so on. This is the second part. Uh, I also I joined the budgeting period in September to November. We know how much what is next year going to look like, and how much energy do we need to purchase, how much scrap and alloys, and so on and so on. And finally, also since we are a group, we make some strategic planning, shifting volumes, because it's difficult nowadays to grow. I think in the European industry, you rather shrink, at least in the special steel industry. That's where we work on, because we are heavily dependent on mobility. Mobility is automotive,
Mm-hmm.
it's aviation, and it's also a little bit a train application. So and also the automotive industry with all this electrification, electric cars coming from China and so on, or Tesla is having a hard time in Europe. Yeah.
Mm-hmm. Mm-hmm.
So these are my main duties, also to participate in some different relocation scenarios and volume shifting and so on and so on.
All right. Thank you. Bernhard, we mentioned your result regarding decarbonization targets, and I understand that to achieve, is there a lot of effort to change the process? And let's discuss about the importance of change, of the ability of people in the steel mill to adapt and stay engaged. And in your company, how can company create a culture of change in between people? Because in general, people hate changes.
Changes. This is something I can confirm. And maybe let's talk a second about what you said, the green steel. The
Mm-hmm.
green steel in our group, there is no clear definition about green steel. There's no labeling system yet, and so on. but it consists mainly on two things. You have to produce steel environmentally friendly, which means
Mhm.
you should have a high circularity, that you use scrap rather than iron ore, and less ferroalloys. And the second point is that you try to use green energy, which you can buy with GOES. These are guarantee of origins. You pay a little bit money per megawatt hour, and then you get a certificate saying the electrical energy you have used is green, is coming from a green source.
Mhm.
And uh, we are quite successful in this green steel making because by luck all our plants we all our plants are based on electric arc furnace. We
Yeah.
do not operate a blast furnace. With a blast furnace, you have a completely different approach, and you have a long way to decarbonize. In our case, it's a little bit easy, but also we have committed ourselves to further reduction by this joining this SBTI Science-Based Target Initiative, where we approximately decrease our footprint by 2030 by 25 or 20 by 25 or 30%,
Mhm.
depending on whether you talk on the melt shop rolling or rather on the downstream processing. And we also promote this because we want to drive this green steel, and we see also some customer acceptance. We do have some customers who say, yes, we want green steel and we are ready to pay for it.
Mhm.
Everybody wants green steel, but we see now more and more readiness also to pay a premium for this, mainly coming from the automotive industry. And why do
Mhm.
they do it? The customers like you, or I don't know, they are open to green technology. And let's be honest, if you buy a car for 50, 60, 70,000 euro,
Mhm.
then the impact on green steel on this car is very little. We are talking about a few hundred euro, which you would have to add on as a premium.
Mhm. Mhm.
We
Mhm.
also supply steel to traders. And a trader, he wants to know what is the price, what is the lowest price, what is the delivery time, and what is the guarantee you can get. So there are different scenarios. But luckily, we see more and more that there is, at least in Europe, there is a acceptance. It also makes sense to decarbonize because we are saving on CO2 certificates. Yeah. And the only problem we have as an exporting company that the add-on prices we have in Europe don't matter in the USA. For example, if you supply steel to the US as we do, yeah, they don't care how much you paid for the certificates and what kind of efforts you did. Uh, so you know that this CBAM is coming in, this carbon border adjustment mechanism. This
Mhm.
will has already started with notifying uh, importers how much CO2 they emit. But from next year on, I believe, if I'm not mistaken, they also have to pay a premium for the CO2 difference
Mhm.
they have compared to us. So this means if there is as an example, somebody from India who sells steel into Europe with a high CO2 footprint, he will have to pay uh, like a tariff on CO2. Um,
Mhm. Mhm. And as I see that with green steel, it's like a kind of strategic point of view for Steel Group. Yes, yes, because it's something what separates you from other players. I don't.
I wish we had a unique selling point, a
Mhm.
USP, but we don't. This is a trend which you see in Europe generally, especially in Germany. And you know there are these countries roadmaps to net carbon zero. So every country has uh, defined a timeline to
Mhm.
become net zero, to have these net zero emissions. I think a big cluster of countries is ready in 2050. Germany is in 2045, Austria in 2040. But the main players in the steel industry, like USA, they have canceled under Trump. You know, they don't care about it. The big ones in China, they want to be decarbonized in 2060, and India in 2070. And
Mhm.
this means now that actually this what used to be a race for net zero emissions has now become a play of a game of Mikado. So the first movers, if you move first, you lose because you have add-on prices. You have to pay money for green steel, and the others don't. Everybody who's competing against you has an advantage compared to you, and that's why we welcome this CBAM, which makes more or less a level play. Yeah? But to be honest, European Union produces 100 million tons of steel per year. Worldwide, we produce 1.8 billion tons per year. So what we do here is maybe a pioneer or a role model, but it doesn't actually change the CO2 emissions, the green the greenhouse effect. Not at all. Uh,
But it is still.
And
Mhm.
uh,
So.
and coming back to the question of the culture, this is really something a day-to-day struggle. For example, my Swiss Steel Group, we changed the name. We used to be called Schmolzen Bickenbach some 5 years ago, and Schmolzen Bickenbach was a trading company, successful, who started to buy melt shops, steel
Mhm.
plants.
Mhm.
Swiss, also von Moos and so Deutsche Edelstahlwerke, and so they bought 5 plants all over the world, and every plant had its own management style, its own business culture. And until today, you still see, I still see this kind of different culture when I visit these plants. So to make a transition, to make a successful change, I have not no answer for this. This is probably the most difficult thing in management.
Mhm. 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 And so I understand that. So, and when you provide these changes regarding decarbonization, so it's like initiatives from top managements. You do some,
Yeah.
you spread it to the people, but you don't have any special internal training programs regarding change management. That changing is very important, etc. It's like.
No, you're right. So this decarbonization or also like safety issues and so on, this is
Mhm.
the top-down approach. You say, I'm committing myself to a decarbonization program. In our case, it was this SBTI, and they have 2 milestones for 2030, 2038,
Mhm.
and uh, and by 2038 we need to be decarbonized by minus 90 by 90%. And
Mhm.
uh, and then of course we at each of our plans has to develop a business plan how to get to these 2 milestones. Yeah.
Mhm.
Same is in terms of uh, top down. You have this kind of KPIs, LTIFR, lost time injury frequency rate, and so on. This means by you record every 100,000 hours of operation, how many accidents do I have? You have to report accidents. You have to report near misses. You uh, you 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 have some standards on not only on safety, also on cleanliness,
Mhm.
shop. How shall I say? Uh, uh, housekeeping, having housekeeping, and this is all coming top down. And then we have one guy or a small group who verify. It's kind of like an internal auditing. They see they go from plant to plant, even myself sometimes, and say, so show me your housekeeping, show me your decarbonization roadmap, and so on and so on.
Mhm. I understand. Okay. Let's go further. Artificial intelligence. Today's what is the stage of is artificial intelligence integration in your company today? Can you share some results or some practical use cases?
Yes. So we are more and more approached by smaller startup companies, bigger companies, or very big companies who offer their AI technology. And I'm just learning now how many opportunities you have in steelmaking. Many of them, they look on your raw material basket. You have
Mm-hmm.
different scrap types, you have alloys, you have alloyed scrap, and so on. And they don't make a kind of linear regression or the dynamic regression to help you optimize the low cost material basket. Uh, you feed the AI tool with the last 10 years and with all kind of information on scrap supply, on claims and whatever. And their AI tools uses this data to learn and to predict the next best scrap or lowest cost material basket for your next heat. So which means you still achieve your properties and your chemistry by using the lowest cost scrap mix. This is one thing. Then we have AI tools for energy management. You know, now in Germany you have very high energy prices and most of all grid cost, which means you have to manage not only the consumption, so the megawatt you are using in a given. We have furnace models and so on. So there are numerous AI tools. However, I have to admit that we are still at early stages. We are with one company quite far to implement, hopefully this year, uh, scrap-based scrap optimizing tool based on AI intelligence. But I would say our company, unfortunately, is not a pioneer in AI.
Mhm.
On the other hand, personally, probably you as well, I use now ChatGPT, I use Google Gemini, and so I hardly use the Google search engine. And
Mhm.
and even if you use the Google search engine, you get connected automatically to the Gemini. So this has already been introduced by all users, and this will more and more come. I'm 100% certain on it. And I see also on reporting, you have to make this recurring sustainability reports, and you can feed those tools with PDF documents, and just tell them, make me a summary in English, 2 pages or 20 pages, and this is really a great tool. Yeah. So unfortunately, as I said, we are not using it enough, but I can believe that the first movers in this particular case on AI, they will be awarded. So there will be a win-win situation.
Mhm. 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 So,
Many AI companies, they're also very convinced about the technology. They offer performance-based payments. They say, okay, my tool costs you 1 million, but you only pay 200,000 or whatever, and the rest is paid by performance. So
mhm.
by your savings. So they
Yeah.
are very confident, and I believe in this.
Mhm. Yes. And do you feel any conflict of interest between like artificial intelligence and metallurgists, for example, if some metallurgists will lose their job or etc. Like,
On metallurgists, I don't see this. I would say metallurgists and hairdressers, they are safe because it will take a while before before a hairdresser, before your hair will be cut by a robot or by somebody. I
Mhm.
can I can imagine that in these recurring jobs, if you are working in accounting,
Yeah.
if you are working in bookkeeping, or if you are a tax accountant and so on.
Mhm.
I can imagine that in this case, this will be the first area where this AI kicks in, and of course in communications. As I said, with reporting and so on, this is a quick win. On
Mhm.
metallurgy, I think we will rather use AI as a metallurgist to optimize the process. I'm not afraid that an AI model will send you home and run the shop by itself. I don't see this.
Mhm. Okay, okay. It's good explanation. Hairdressers and metallurgists. Okay. So I have my final question, and then we have question from the audience. Finally, from your point of view, what does steel plant look like 20 years from now in 2050, for example?
Yeah, if I look back 25 years, I have to say changed in terms of mechanical part. You have this ladle furnace, maybe some secondary metallurgy and so on. And of course, uh, these big processing units, they have optimized incrementally. You have better electromagnetic steering, or you have better uh, uh, um, transformers and so on. What I'm sure will improve is a kind of a diagnostic tools that your process will become more and more transparent. Give you an
Mm-hmm.
example of the mold in continuous casting, for example, is still like a black box, and this will become more and more uh, transparent by digital twins, by modeling and by other things. I'm sure that there will be less and less people working in the shop floor, mainly for safety reasons. Yeah. And I think that I'm not sure if we will still have so few big companies like, I don't know, like Bausteel. Okay, Bausteel is not a shop which produces 100 million tons in one location. But there are, for example, I give you an example in China. There is a city called Zhangjiagang, 6 million or 5 million inhabitants. There they produce uh, 50 million tons of steel in one city.
Mhm.
So I'm not sure if this such a cluster will remain, especially for rebar. I can imagine uh, that with this MEDA technology, promoted by Danieli,
Mhm.
uh, for 100,000, 200, 300,000 top ton shops, you will get your scrap from a big city nearby. You will produce rebar and sell it back to the city.
Mhm.
Like there was a case in Denver. There's not much, there are not many big companies around, sorry, cities around Denver, but Denver is a 4 or 5 million inhabitant city, so there is scrap available.
Mhm.
And then what you could do, you could build a small shop for 100,000, 200,000 tons on the outside of Denver, get the scrap, melt it with an induction furnace or electric arc furnace, directly casting, directly rolling, also linking casting and rolling without reheating furnace, and then you produce rebar or bar in coils or whatever, and and then send it back to the city, so that
Mhm.
there is a kind of microscopic steel plants. I can imagine this will also increase more and more. And these meter plants, we have at least, I think now 8, 9, 10. You have them in Egypt, you have them in the United States. I'm not sure if there is one in Europe, but these are small plants with a single product, mainly rebar, so steel, simple steel, highly efficient and serving a local market.
Mhm. Mhm.
This I can imagine that this will become more and more.
Okay, okay, thanks, Berhard. Let's I will open the chat. So we have questions from the audience. Consider the steel making process. Is it correct we say to eliminate carbon? Is the steel making without carbon? Like I think it's a question regarding decarbonization.
No, not necessarily.
Mhm.
Uh, because first of all, we have this big two of, was this a question or is there anything else coming, Andre?
Can repeat. Consider the steel making process.
Yeah,
Is it correct we say to eliminate carbon? Is the steel
yeah,
making without carbon?
yeah. So I think this question is reasonable, and we have to look at two approaches. First of all, when you make integrated, when you have a blast furnace and iron ore based blast furnaces, how much carbon does a blast furnace need? 300 kilos, 350 kilos. And this is an efficient blast furnace. If you have a small mini blast furnaces, you can easily go up to 800, 900,000 kilos of coke per ton of hot metal. So uh, here uh, there will be a reduction. Here there will be a process transition away from the blast furnace to the DRI plants, like we have in the Middle East, for example. So the DRI plants, they will still use iron ore as a feedstock, but for now, the iron ore will not be reduced by carbon, but by natural gas, and in the future by hydrogen. And doing so, your carbon consumption will decrease from, let's say, 300, 400 kilograms per ton to maybe 50 kilograms per ton. So this is one thing. But also on the electric arc furnace side, on our Swiss Steel Group steelmaking technology, we also use carbon for foamy slag, for alloying, because we have sometimes tool steel with 2% carbon.
Mhm. Mhm.
But our carbon usage per ton steel is much less. We use maybe 5 to 10 kilos,
Mhm.
not 300. And
Mhm.
also here we are talking about replacing anthracite or petrol coke with biochar coal. So,
Mhm.
so coal which comes from coking eucalyptus trees or whatever trees. So also on our level, we still want to reduce our carbon usage or to replace the carbon with bio coal,
Mm.
biological coal. Uh,
Okay.
there will always be a reminder. I don't see a replacement for graphite electrodes. On the electric arc furnace, you have graphite electrodes, 1, 2 kilos. Stainless steel is 3 kilos per ton steel. You have electrodes on the ladle furnace, and I don't see that there is a kind of water-cooled electrode which can replace the graphite electrode in the near future. So
Mhm.
there will always be a certain minimum, which at the moment I don't see can be that you can completely get rid of carbon in the steel industry.
Mhm. And what do you think about new technology like Boston Steel? As I remember, I'm right. It's like reduction by hydrogen, yes, or by electrolysis.
Yeah, by electrolysis, I think this is a very interesting approach. I don't know enough about it. I read about it, but in the end, uh, reducing iron or a reduction process
Hmm.
actually is is you trons. On the other hand, if you make an oxidation, you give away electrons. So it's an electrical process, and
Hmm.
I think this Boston Metals, or what the name is, they have collected millions of money. So they have a lot of money from Amazon and from everybody, and they built a pilot plan and trying to feed iron ore and to get out something like I don't know, is it a hot metal or is it a liquid steel?
Hmm.
Uh, but I think the technological readiness level, so the TRL, which goes from 1 to 10. So 1 is an idea, and 10 would be industrial process. So the
Hmm.
TRL, the technological readiness level of
Hmm.
this process, I don't think is too high. But
Hmm.
maybe I'm mistaken,
Hmm.
and these guys are much further there. But it's an interesting approach.
Hmm.
Of course, it makes sense. You need to have a lot of electrical energy. If your if your electrical energy comes from a coal-based power plant, then you don't need to do this exercise. You
Hmm.
must have electricity from renewable energies.
Okay. Next question. Looking back at your journey from metallurgist to director of corporate technology with global experience and first-hand insight into technological transformation, what advice would you give to next generation of metallurgists and engineers who aim not only to succeed professionally but also to shape the future of the steel industry by 2050? Do you hear me? Berhard?
Yeah, you were breaking up a little bit. You were breaking. I hope I understood the question. Yes. So it was about young talents who want to enter uh, the steel industry. So I think you have to be first of all honest to yourself. You have to to see where do you want to be in 10 or in 20 years. Not everybody is born to be a leader. So of course when I was young I wanted to be a CEO. I will never be a CEO. uh, some guys are very happy. They love technology, they love metallurgy, they love the life in R&D, for example. Yeah. And what I said 1 hour ago is true. So you have to like the job you are in. So don't try to make career because of the money and so on. Yeah, look at yourself, and if you say yes, I think I can, uh, I can manage people. I like to be involved in decision making, holistic decision making. Then you could try to add an MBA, because I've seen many of my colleagues. They have metallurgical or technical expertise as a base, and then they added an MBA, master design of business, a master degree of business administration, which takes 1 or 2 years, costs of course a lot of money, and suddenly they distinguish themselves from the pure technician, or from the pure guys who studied business administration but has no idea in steel making and so on. Yeah.
Mhm.
Uh, I also find, don't be afraid of uh, working on interfaces. So I worked in melt shops, in rolling mills, in different plants, and so this kind of, I consider myself rather a generalist in many things than a specialist in one thing. I could not run an electric arc furnace. I could not run a rolling mill and so on, but I have maybe an idea about what it takes. So be honest to yourself, and then if you have decided you want to be a manager, for example, then also don't be afraid of changing jobs. It's very important how you get along with your direct boss. If your direct boss is helping you, trying you with some programs and so on, yeah, then you're in good hands. But then there are other bosses who rather want to make their own career, and they don't care too much about you. So there are so many different approaches.
Yes,
But
yes.
don't be afraid of new things, of new people, and that's what the advice I can give.
Thanks, Bernhard. Bernhard, we have some questions. Do we have 10, 15 minutes? I don't know. So is it
Yeah,
okay
yeah.
for you? Because
I'm free. I'm
one
free.
hour lasts like 1 minute. So next
Yeah.
question is like more technical. I don't know if you can answer. My question is how I will reduce carbon in induction furnace melting for casting stainless steel.
How to reduce? Was it to reduce
How I will reduce carbon in induction furnace melting for casting stainless steel.
casting stainless steel? Yeah, I know induction furnaces. First of all, they are very popular in India. They are very popular for smaller heat sizes, and small heat sizes fit very well with uh, 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 with stainless steel because then the order size is not so big. So and India has a strong history of a chromium ore and also strong history of uh, stainless steel making on based on induction furnaces. Personally, we don't have induction furnaces. I know that when you feed the induction furnace with DRI, then of course the gang, what's inside the DRI, and the carbon content of the DRI, which can be adjusted from, let's say, 1 to 3.5%, can help you to decarbonize the DRI. So if you have a gang with a high amount of SiO2, for example, silica, uh, then this oxygen in the SiO2 can help you uh, decarbonize the DRI. You have a lot of slag, but then what remains in the uh, in the induction furnace is already low in carbon, lower than the original DRI. Then the question is, of course, what kind of stainless steel do you want to make? If you want to make a martensitic steel, which can easily have 0.1% carbon, in this case, uh, probably you can do without VOD or AOD. But if you go for stainless and ferritic steel, especially for the L type, the 304L, and so on and so on, where you have carbon level of 0.01 and 0.02%. I think in these cases, I have not heard, I don't think you can work with an induction furnace only. Then you would need to have probably a VOD or an AOD converter to remove the carbon by oxygen blowing.
Mhm.
But I'm not the right expert on induction furnaces. I believe, especially in India, there are many, many more competent people to answer this question than me.
Mhm. Okay. Thank you. The last question. Maybe have time to ask and discuss how analyzer reduce energy consumption instead of lab samples, pickling acid, rolling emulsion. You know, my third project is to start digitalization for carbon reduction by reduce energy, scrap, process repetition.
This was about an analyzer, you said?
Yes, yes, I think it's about analyzer, some sensors.
Okay, okay.
Mhm.
Of course, analyzers for the different types of analyzers. The easiest one is the spectrometer. It looks like a handgun. When you walk on the scrapyard, you don't know what kind of scrap you have in front of you. You make uh, uh, a real-time analysis. So with a spectrometer, you hold against the scrap piece, and then you get the analysis. I think this is not the question you were asking. On the electric arc furnace, you have an off-gas analyzer, yeah, which
Mhm.
helps you analyze the off gas in terms of CO, CO2, temperature, pressure, and so on. And by doing so, you are supposed to be able uh, to control your furnace to make it more energy efficient.
Mhm, mhm,
We have the same on VOD, where on the VOD where we put the stainless steel ladle to a into a chamber, seal it, and then we apply vacuum and blow oxygen, inject oxygen from top. We have an off-gas analyzer who tells us, who gives us some process transparency and tells us when to stop blowing the oxygen. And
mhm,
finally, I've seen spectroanalyzers for scrap for scrap analysis. So this is called of LIPS system, laser-induced breakdown spectroscopy, where you try to segregate, to sort different pieces of scrap by analyzing them in a tenth of a second, and then segregating by copper level, by level of molybdenum, and so on. But this is something which is rather technology used by scrap dealers than by steel makers.
mhm, mhm. But this analyzing information, collecting information, data, measure some parameters is very important because of this digitalization, artificial intelligence. Yes, because it's becoming more and more important to collect
Yeah,
information about.
yeah, yeah.
Okay. Okay, Berhard, many thanks. I I enjoyed our this hour with you. So I understand that I think that we discussed maybe even less than 1% that you know. Yes, you have a huge experience. And thanks for your sharing. Thanks for your openness. Thanks for your kindness. It's like also contribution to young generation. And I see that you're a passionate metallurgist. And yes, and I wish you all the best. Yes, to become in the industry at least next 30 years, at least till 2050. Yeah.
Yeah. Thank you very much, Andre, also for providing me the floor today. As I said, I'm not a top manager. I've gained a little bit expertise since 1991, as you told everybody. Now you and I, we almost are friends. We have not met in persons, but at least a few times now on the internet. And if I could help anybody in this last hour, then my mission has been accomplished, and this was a big pleasure for me as well. Yeah.
Thanks, Berkhard. And I would like of the audience, if you like this meeting, this event, share your comments on LinkedIn so it can spread this podcast for other people. And so I think that Berkhard also will read comments with pleasure. Yes, and thanks so much for everybody.
Okay.
So yes, thanks Berkhard, and let's stay in touch. See you somewhere.
I hope so. Yes. Thank
Yes.
you very much and goodbye to everyone. Huh? Bye
Okay.
bye.
Bye bye. Bye bye.